Basics of calculus. Calculus helps us understand how things change. It is the mathematics of motion and growth, helping us find out how quickly things change, which we call derivatives, and the total outcome of these changes, known as integrals. Whether you're calculating the speed of a car, the growth of a plant, or the total amount of material needed for construction, calculus gives us the tools to answer these questions. Derivative. A derivative, written as f prime of x or df over dx, measures how a function f of x changes as x changes. It's like looking at the speedometer in your car to see your speed at a specific moment. For example, if f of x equals x squared, the derivative f prime of x equals 2x, telling us how x squared changes as x increases. Integral. An integral, written as the integral of f of x dx, adds up all the tiny changes in f of x over a range to give the total accumulation. Imagine adding up all the little distances your car travels in a minute to get the total distance. For example, if f of x equals x squared from x equals a to x equals b, the integral from a to b of x squared dx computes the total area under the curve. Practice problem 1. Find the derivative of f of x equals 3x cubed minus 5x plus 2. Solution. To solve this, apply the power rule. The derivative of f of x is f prime of x equals 9x squared minus 5. So, the derivative of f of x is 9x squared minus 5. Practice problem 2. Calculate the integral of f of x equals x squared from 0 to 3. Solution. To find the integral, use the formula for the integral of x squared. The integral from 0 to 3 of x squared dx is x cubed over 3, evaluated from 0 to 3, equals 27 over 3, minus 0, which equals 9. Therefore, the value of the integral is 9. Example 1. Using derivatives. Problem. Calculating the instantaneous speed of a car when its position over time is given by the function s of t equals t squared plus 3t, where t is time. Step by step. First, find the derivative of s of t. The derivative of s of t, or s prime of t, equals 2t plus 3. To find the speed at any time t, use the equation 2t plus 3. For example, at t equals 1 second, the speed is 2 times 1 plus 3, which equals 5 meters per second. Example 2. Using integrals. Problem. Finding the total distance traveled by a car if the speed v of t equals t plus 2 over a time interval from 0 to 5 seconds. Step by step. Set up the integral for v of t over the interval from 0 to 5. The integral from 0 to 5 of t plus 2 dt. Calculate the integral, which adds up the speed at every instant to give the total distance. This is the area under the speed time curve from 0 to 5. Quiz time. What does the derivative of f of x equals 6x squared tell you about the function? If you have a function g of t equals 5t squared, what is the integral from t equals 0 to t equals 4? Calculate the rate of change for h of t equals t cubed minus 3t at t equals 3. Find the total accumulated value for f of x equals 7x from x equals 1 to x equals 5. If the acceleration of a vehicle is given by f of t equals 3t squared plus 2t plus 1, what is the change in velocity from t equals 0 to t equals 2? Let's go over the answer to the quiz questions. What does the derivative of f of x equals 6x squared tell you about the function? The derivative of f of x equals 6x squared tells us how the function changes as x changes. Specifically, the derivative describes the slope of the function at any point. The derivative of f of x, which is f prime of x, equals 12x. This means that as x increases, the rate of change of f of x increases proportionally to 12 times x. If you have a function g of t equals 5t squared, what is the integral from t equals 0 to t equals 4? To find the integral of g of t equals 5t squared from t equals 0 to t equals 4, we first apply the formula for the integral of t squared. The integral of 5t squared dt equals 5 times t cubed over 3, evaluated from 0 to 4. This becomes 5 times 4 cubed over 3, minus 0, which simplifies to 265 thirds. Therefore, the integral is 265 thirds. Calculate the rate of change for h of t equals t cubed minus 3t at t equals 3. To calculate the rate of change, we need the derivative of h of t. The derivative of h of t, or h prime of t, equals 3t squared minus 3. Now, substitute t equals 3 into the derivative. We get h prime of 3 equals 3 times 3 squared, minus 3, which simplifies to 24. So, the rate of change of h of t at t equals 3 is 24. Find the total accumulated value for f of x equals 7x from x equals 1 to x equals 5. To find the total accumulated value, calculate the integral of f of x equals 7x from x equals 1 to x equals 5. The integral of 7x dx equals 7 times x squared over 2, evaluated from 1 to 5. Substitute these values to get 7 times 5 squared over 2 minus 7 times 1 squared over 2. This simplifies to 84 over 2, which equals 42. Therefore, the total accumulated value is 42. If the acceleration of a vehicle is given by a of t equals 3t squared plus 2t plus 1, what is the change in velocity from t equals 0 to t equals 2? To find the change in velocity, integrate the acceleration function of t from t equals 0 to t equals 2. The integral of 3t squared plus 2t plus 1 dt equals t cubed plus t squared plus t, evaluated from 0 to 2. Substituting the values, we get 2 cubed plus 2 squared plus 2 minus 0, which simplifies to 14. Therefore, the change in velocity is 14.